with this probability question, right? It says there are X black pens. Okay, so we don't know how many black pens we're dealing with. But then they then told us that we have 3 red pens also. So in total, we don't know how many pens. It's technically going to be X plus 3. But then let's carry on. We read the question first and then we read it again while writing out what we can write out. It then says here, you randomly select 1 pen from the box and then return it to the box. You then randomly select a second pen from the box and return it to the box. Suppose it is known that the probability of you selecting 2 pens of the same color is 5/9. Calculate the number of pens in the box. So we have read the question. Now we have to read it again, writing out what we can write out. The important thing is, they say here you have X black pens. So pens that are black, you have X of them. See? And then red pens, you have 3 of them. And then they say here, you randomly select 1 pen. But before you worry about selecting 1 pen, the total here is just supposed to be X plus 3, right?
Yes.
And then it says here, you then randomly select 1 pen from the box and return it. So a situation like this, as you stated already, it needs a tree diagram, because a tree diagram can help you trace these events in terms of probability. So what happens is, in the beginning, you're either going to choose a black pen or you're either going to choose a red pen. But the thing is, the probability of choosing a black pen, the amount of black pens you have, it's X, you don't know, but the total is X plus 3. The amount of red pens is 3, but the total is X plus 3. So the idea is, once you choose a black pen, if you're going to choose a pen again, 2 options again. You either choose another black one or you choose a red one. But if you chose a red one in the beginning, still, the second time you choose a pen, it's either going to be a black one or a red one. So this is showing 2 different alternatives of events that can happen. So choosing a black now, remember they said that you then randomly select a second pen from the box and return it. But the thing now is, they said here, when you took out the first one, you also returned it. So in total, you still have X plus 3 black pens. And in total, you still just have X black pens. Here, the red ones, in total, you still have X plus 3 pens. In total, you still have 3 red pens. Same here. And for this branch, total, you still have all your 3 red pens, and you still have all your X black pens. And then they said, yes, suppose that it is known the probability of getting 2 pens of the same color. So before we worry about that, getting 2 pens of the same color, there's only 2 options. You're either going to get a black after and then a black before, a red after and then a red before. The probabilities of that happening, a red before and a black before and a black after, you have to multiply those probabilities, right? So it's basically X over 3 plus X over X plus 3 squared, because you multiply them together. Same here. This is going to give you 3 over X plus 3 squared, because you have to multiply this and this. That's the probability of getting red and red. But then they say the probability of that happening is 5/9. But the thing is, there are 2 scenarios where you get 2 colors that look alike. There's scenario number 1, and then there's scenario number 2. So you have to add up these 2 scenarios, right? For you to get the 9/5 that you wrote there. So that's what we're gonna do. You see, the 3 over X plus 3 squared, we're gonna add it to the X plus 3 squared. This is gonna give you 5/9. Now, this 5/9, if we're gonna solve for X here, we can just mark, the square means it goes for the top and the bottom. So this is gonna be 9 over X plus 3 squared. Here it's gonna be X squared over X plus 3 squared. Now, the fortunate thing is we have 2 things at the left that have the same denominator. So normally when you have a situation like that, you fortunately can just put these over that same denominator. 9 plus this squared gives us x plus 3 squared. So the left side looks like we can simplify. Let's just write this like this, just so that you can see that we have something that we don't have the difference of two squares, but if you look at what we have here, you ask yourself, can this maybe be factorized until it at least maybe has one bracket that looks like this? You could be playing around with that idea. So
okay.
yeah, you could be thinking, you could be thinking of factors of 9 that give us 0. That's like 3 and 3. But to get a 0, you have to say plus 3 minus 3. Wait, how come that's the difference of two squares now? This doesn't make any sense. This doesn't work because negative and a negative gives a plus, gives a minus. So this doesn't work. So it has to be, let's see, 1 and 9 doesn't work. 3 and 3 doesn't work. So here we cannot factorize this top. We have to leave it the way it is. If it has the difference of two squares, fine, but it's not.
So it was x squared minus 9.
Pardon?
Oh no, I'm just saying if it was x squared plus minus
Yes.
9.
Yeah. So now the one thing you can do here is to just cross multiply. You don't have to worry about getting an LCD. 9 times this bracket, you have 9 times this times the 5. This is what you have. Now, since we're solving for x, right, we just have to be very careful because things can go south very fast, but just have to keep our cool, you know, just have to keep our cool. So let's carry on here. Here, what do we need to do? X plus 3, right? So it's 5 here. X plus 3, if you're gonna FOIL that, you're gonna have 6x plus 9 here. Then here you're gonna have 9x squared plus 81. Multiplying inside, you're gonna have 5x squared plus 30x plus 45. Then you're gonna have 9x squared plus 81. Everything on one side, you're gonna have the 9x squared minus 5x. Everything on one side some more, you're gonna have minus 30x and then plus 81 minus 45. You see it?
Yeah.
Squared, the squared, got the squared. And then this is just a 4, x squared. 30 does not have a like term, so you have your 30 there. 81 minus 45 gives you 36, which is a bit promising, but we can just use the quadratic formula for this one. Then the quadratic equation over 2a minus b plus minus c squared.
Okay.
Minus 4a c over 2a. Like that.
Okay. So for the first answer, right, it's x minus 6.
Wait, it's not giving
Wait,
us like a
sorry.
nice.
For the first answer, it's x equals to minus 6.
Mm-hmm.
And then the second answer is x equals to minus 3 over 2.
Yeah. So that makes sense to a certain extent. So now we have to assess the question and the answer. So the problem with these answers is they don't make sense because x has to be a positive number. So we just have to see what we did wrong somewhere because x cannot be a negative number. Do you understand?
Okay.
Yeah. So tracing our steps back, right? We can start from the top. We said this squared plus this squared gives us 5 over 9. So we squared the top, fine, squared the bottom. Squared the top, squared the bottom. LCD, fine. These two added up. Cross multiplied. 5 times this bracket, 5 times 9 times this bracket. Then we said x squared, then you have 3x plus 3x, and you have 9. Multiplied inside, multiplied inside, multiplied inside. Take everything on one side. 99x squared and negative 5x. And here came a negative. 81 is still there. The 45 became negative. 81 minus this, we got a 36. So everything looks all fine. It's just crazy how we're getting a negative. But to test it out, we have to put our answers here and see if they give us a 5/9. If they don't, obviously we know something's wrong. So 3 over negative 6 plus 3, the whole thing in brackets squared, and then plus what you call negative 6 over negative 6 plus 3, the whole thing in brackets squared. Let's see what that gives us.
5.
It gives a single 5. So there's something wrong from the top here. Let's just find it. Because if it's a subtle, no, let's try the negative 3 over 2 also. Because, yeah, negative 3 over 2. And this is also negative 3 over 2. The other one here is negative 3 over 2. That's also a 5. So yeah, the issue is the answers. But let's see what the problem is. Let's see. This squared is 9, this squared is that. This squared is this squared is that. And then over 9. 9 times the top part, 9x. 9 times 9 is 81. Yeah, this is just a bit annoying now because it's like, wait, why are they not working? Why are they not working? 5 times 9 is 45. Okay, what you do is you can just sub in, we can just sub in our value of x's for each step. No. From the top here, they don't balance out. So it means this answer is right at the bottom of the issue. If you go back here, this is going to be an issue, obviously. If you go back here, our A, B, and C value is an issue. If you go back here, 9 minus 5. Yeah, that's fine. The 30
It says
there,
minus 30x.
minus 30. Oh, yeah. There's the sign issue. Yes, thank you. There's our error. So we have to just change that. Because if we're not finding an issue, a sign is definitely to blame 99.99% of the time. So there's negative.
Okay, so everything is positive now instead of negative.
What answers are we getting?
Let me test them out.
So let's see, negative
So
30.
with the 6, I'm getting 5/9. And then with the negative 3/2, wait, the positive thing 3/2. Let me just.
Yeah, but we cannot have 3/2 tens. So the 6 is the only valid answer.
Oh, it also gives me 5/9 though.
It does, but logically speaking, the question does not allow us to have 2/2. You cannot have 3/2.
Oh, because you can't have a 2/3
So
or
realistically
10.
speaking, only x's
Yeah.
can be 3 here. You see, this one you have to disregard it. You get it?
Oh, okay. So what if it's
If it was a
it's
normal
for
algebra question where they just say solve for x, you take both answers. And then this is not just a general algebra question. So we just have to use one answer. The one that makes the one that makes sense based on the scenario.
Oh, okay. So there will never be a scenario whereby you use a fraction to get our answer.
No, an answer can be a fraction. We're just saying this situation. You cannot have 1.5 pens. You have either a full pen or another full pen, and another full pen. You don't have like half a pen.
Okay,
So
so would
for
the 3
for the,
over
for
2 work when there's like, for example, a cake that gets cut in thirds? I mean, yeah.
the 3/2 can work for any other scenario that does not have, let's say, a real life implication, that does not take fractions. So if you're talking about people, 3/2 would not work because you can only have a full person. If you're talking about objects, you can also only have a full object. But if it was a normal, if we had just been given something like this and they said solve for x, fine, we would take both answers. But then this scenario has a specific, what you call, there's something specific that they want us to be working on for this question. So you cannot just take all the answers and leave them like that.
Okay.
Yeah. You get it?
I get it. Thank you. Thank you very much.